you. Now that you have all got a bit of an introduction with regard to Project DemLENS, we are going to dive into the real backbone of the project, which is narration and how we can explore spoken language data. The aim of the study, as we said before, is to give a detailed description of the linguistic profile of speakers across the AD dementia continuum. The outlook in research initially was focusing on cognitive skills, memory, executive function, but there is a shift with regard to research worldwide. We are paying more and more attention with regard to multimodal data resources and also language-related measures. Now, as linguists, we need to come forward and be able to respond to two questions. Number one, can we use language production to assess linguistic decline effectively? And if yes, which are those language indicators that we can interpret within the broader context of neuropsychological assessment and have predictive value in the development of dementia? Why would we look into language production? Discourse is a complex linguistic activity because it involves different levels of the linguistic system. So you get phonological, morphosyntactic, semantic lexical, and semantic pragmatic information that work together with cognitive aspects. But when you're looking in narrative discourse in particular, you get added information, and that is because you get the verbal reproduction of an episode by linking facts, integrating scenes, and establishing the relationship among the events. When you have this level of complexity, it gives you the chance to have measures that have to do with lexical, syntactic, and content complexity, which is something that we don't get in more strict tasks, let's say a sentence repetition task, as we saw before. Now, is there any early linguistic decline? In healthy aging, not much. Microstructural aspects are maintained. Some subtle communicative difficulties if you test for them, though. What is happening with regard to subjective cognitive impairment? Well, there is a recent study by Ludholm, Fraser, and Kokinakis who analyzed Swedish data, and they measured dependency, distance, phrasal type, proportion, and length, and they didn't find a difference between the SEI group and the healthy control group. When we're moving to MCI data sets, we find some impairments with regard to comprehension, but overall we have retained global coherence and referential cohesion with some shorter sentences and fewer left branching structures in story retelling. How about the AD data? Well, it's no surprise that we have clear effects with regard to the lexicon. So lexical access difficulties as they manifest through lexical substitutions, use of indefinite terms, etc. And also a lot of semantic memory impairments. So when we ask them to categorize, for example, or use priming to test an effect of semantic categories. In morphosyntax, there is indeed some difference, and the preliminary research showed that we have to look towards structures and agreement difficulties maybe. And when we're looking at the microlinguistic level, we find that there is an overall reduction in the information content of speakers' production, and that can be easily measured by looking at the use of indifferent pronouns, fillers, and explicit states from speakers that they cannot find the appropriate word, but also by looking at changes with thematic roles that are often omitted or incorrectly used or incorrectly assigned. Overall, there is a drop with regard to their discourse effectiveness, and we find that in speakers production with AD, there is poor information management, hence the repetitions or omissions, etc. Now, what sort of data do we have access to? So far, the Dementia Talk Bank has some limited data, very few speakers from English, German, Mandarin, Spanish, and Taiwanese, and no quick data set yet. There have been a couple of studies by Redumi and colleagues. One of the colleagues is also Frankopoulou, whose thesis was published in 2021. They looked at 30 mild moderate AD speakers using single picture description, and they did find systematic differences in lexical variation and syntactic complexity compared to controls. However, they used automatic annotation, which means they used software to annotate and not linguists, so they didn't do like manual tagging. So they analysis is quite promising, but not cross-checked with more than 2 linguists to make sure that you have the exact numbers. Though they do point that there is an overuse of pronouns, so maybe we need to look out for that. And there are some difficulties with regard to reflexive pronouns in clinics and pronoun number agreement. As we said in the previous talk, DemLENS brings together the clinical evaluation, the MRI screening, and the cognitive neuropsychological assessment. So we had a quite extensive battery of tasks for a number of different cognitive functions to make sure that we appropriately place our speakers to the relative groups. We managed to collect data from 178 speakers, and they fall into 5 groups: the young healthy adults, the older healthy adults that are cognitively intact, individuals with subjective cognitive impairment, individuals with mild cognitive impairment, and individuals with Alzheimer's disease and the mild early stages. And this is an overview of the distribution of participants in the 5 groups, plus the 9 outliers that were excluded for a number of reasons, either technically related or because something in their clinical profile was not, would not satisfy the inclusion criteria of the study. Here is the detailed cognitive screening for controls, and here is the neuropsychological assessment of the clinical groups. But let's move on to the language measures. We used 2 types of measures. The first one is a single picture descriptive discourse task. For that one, we used a cookie theft, very well-known picture from BDA. And the second task was a picture sequence narrative discourse task, the flower pot incident, where we have 6 scenes. They are visually presented in the correct order in an A3 sheet paper in black and white. And we ask our participants to simply narrate the story that they see. We opted for picture-supported stimuli for narrative elicitation for 3 reasons. First of all, because we wanted to reduce the demand on memory because the stimulus remained available. Secondly, because that would give us the same baseline for linguistic analysis since we had the description of the stimulus. And thirdly, because we were not providing any linguistic clue that could potentially disguise malfunction. So basically, we were not providing language, we were just using a visual aid. Now, the level of the linguistic analysis when we're looking at spoken language, we have 2 basic levels, microstructure and macrostructure. For microstructure, we have lexicon and syntactic annotation, and for that we use the UAM corpus annotation tool, which is quite labor-intensive manual annotation done by 2 linguists and then cross-checked. And the second level is that of microstructure, where we're examining the manipulation of information content, so narrative effectiveness and information complexity. Today, I'm going to refer just to microstructure because otherwise I would need several hours to explain the macrostructure findings. Let's start with the cookie theft, single picture description. For this analysis, we looked at information units in 4 areas. So actors, places, objects, and actions. And we calculated the number of correct information units, the number of irrelevant information units, empty information units, and then with regard to narration length, we looked at number of words, number of fillers, and of course, narration density that was calculated on the basis of number of IUs used per 10 words. And here is an overview of how they performed. You see in the multiple colors, the different groups, the 5 groups, starting with the young healthy ones in the dark blue. And in the light green one, you can see the AD group. And we have the IUs in percentages with regard to actors, places, objects, actions. And in the last battle, you see the number of correct IUs used in their narration. Now, the statistical analysis showed that when we're looking at the number of correct IUs they use, the number of factors, number of objects, and number of actions, we could only discriminate the AD group to the rest of the groups because there was a significant drop in the number they produced. However, when we are looking at the places, we can easily discriminate between the 3 clinical groups. And the same happens with regard to empty IUs and fillers who increase as dementia progresses. When we looked at the narration length measured in words, again, we found differences between the clinical and non-clinical groups, but we were also very happy to find that both with regard to word length, to number of words for length measurement and the number of seconds for the time measurement, we could finally discriminate between older healthy controls and individuals with subjective cognitive impairment, which we did not find in any of the other measurements. Lastly, with regard to narration density, we find that individuals with subjective cognitive impairment and mild cognitive impairment act alike, and they differ significantly to the two control groups. So something is happening there. Whereas the index with regard to the AD group was not different to the control ones, but that has to do primarily with the fact that the narration is far too short. It's about a third of what the typical speaker would provide. Now, moving on to the flower pot incident, so the picture sequence narrative, here is the framework for the microstructural analysis. For every episode, that story had 3 episodes. We had the setting, so the reference to time and place, initiating event, a goal, an attempt, an outcome, and a reaction to the initiating event. All that accumulated to 30 microstructural points. And apart from that overall index, we also looked at the microstructural complexity. So the number of attempt outcome, goal attempt, and goal attempt outcome sequences, and also any single goals, single outcomes, and single attempts that they provided in their narration. And some extra information on the relevance, so number of actors, objects, empties, IUs, etc. And of course, irrelevant information either about themselves or to elements that are not present in the story. Again, similarly to the quickie theft analysis, we included narration length indexes and narration density indexes. Now, the big picture, looking at the microstructure information, we were able to discriminate between the 3 clinical groups, the 2 healthy control groups, plus the individuals with subjective cognitive impairment performed alike. And also the same sort of effect we have when we're looking at the irrelevant information, with irrelevant information increasing as we progress towards the AD group. A couple of indexes that appear to be of interest and singling out AD participants was that of the number of actors, MDIUs, and fillers. Now, how complex were their narratives? When we're looking at simple sequences of 2, so the attempt outcome, goal outcome, and goal attempt, we can discriminate the AD speakers to the rest of the groups. However, when we're looking at the most strict one, the goal attempt outcome combo, there we find that individuals with subjective cognitive impairment and mild cognitive impairment perform alike, and they differ significantly to AD groups and control groups. However, when we look at single goals, attempts, and outcomes, we don't find any difference between the groups. Now, narration length in that table, apart from reporting the number of words and the seconds it took them to describe, I'm also including 2 very interesting variables, the filler words that they used and the pauses. We find that when we're looking at narration length in terms of the number of words they produced for the actual narration and the time they took, they did not differ. So all groups took the same time, approximately the same amount of words. However, if we look at how many of those words were filler words, we find that they increase significantly as we move on through the 3 clinical groups. And also when we're looking at the pauses, we see that AD speakers take a lot of time to actually plan out their next sentence, next utterance. Also, with regard to the narration density, even though 4 of the groups did not differ to each other, we found that there is a significant drop with regard to AD speakers, which was not attested when we looked at single picture description. So for narrative density to drop, we need a different kind of task. So that sort of effect is concealed when you use single picture depiction. To conclude and summarize the basic language markers that we can look for when analyzing language production data. If you're using a single picture descriptive discourse task, then information content will drop, and information units such as places or empty ones or fillers will help you discriminate between the three clinical groups. Narration length, on the other hand, is going to help you discriminate between healthy older controls to the ones that have subjective cognitive impairment. Remember, those two groups do not differ in terms of cognitive ability. The only reason they are grouped differently is because the ones in the subjective cognitive impairment group report that they feel that their memory skills are different. Okay, and when we're giving them picture sequence narrative description task, what do we do there? Basically, you can use a macrostructure index, a general one, and that will be enough for you to discriminate the three clinical groups. Also, the amount of relevant information they provide will increase as you progress closer to AD. And narrative complexity is a bit more tricky in that you see that certain things remain are preserved, change a little bit from healthy aging to the two preclinical stages of AD, but a lot of the ability is quite retained. So they don't do that bad, except when you're looking at the more complex sequence of goal attempted outcome. Narration length in this case will not be particularly informative, whereas narration density will help you out to single out AD individuals. So what is the next step? We need to look into the individual differences and relate the performance within the groups by looking at their cognitive and language ability overall, because maybe there is some not maybe, for sure, there's variability that is hidden there. And we have to see why and if certain individuals within particular groups do better. So what helps them out in doing better in oral language production? That's all. Thank you.
Excellent. Thank you very much. If there is any question for the audience. Maria, can you tell us something about how did you measure narrative time?
It was a difficult task because we had to calculate, basically we measured the seconds from the onset of the first syllable of their narration. And then we have to remove all the interruption time, for example, or any planning time ahead of the start of the production. And that is how we start with the very first onset of the first syllable they pronounce to the very last one. And we eliminate the time in between in case they ask, for example, clarification questions or there's some other sort of interruption. But it was quite intensive. And especially calculating the pauses, that was very difficult because we had to go between words and between phrases and calculate the time it took. Thankfully, most of the time, their speech rate was quite good, and we had to measure between phrasal constituents and not between words per se. So it wasn't that bad.
Is there any other question?
Okay, when we do manual annotation, it means we identify specific things and we give tags to those things. And it's trained linguists that do that. And you have at least two, and they both need to agree on how you assign particular linguistic properties. Often, this has to do with how you interpret things and not necessarily how they look. And I'll give you an example. For example, in Greek, we have determiners that come in front of nouns that are identical to clitics. For example, to pagoto, to, and το ήπιε ή το έφαγε, which is eclectic. And non-automatic annotation will not be able to identify the difference between the two toes. Okay, so it is quite laborious. However, I think more and more machine learning will have towards that direction because if we give them a fully annotated corpus and we ask them to do it automatically and find the discrepancies, maybe we'll be able to help them out in how to resolve certain issues. And also it would be a very useful tool for us if we could have like 80% of the job done automatically and then maybe for us to fix the rest 20%. That would be so much time saving as opposed to doing everything from scratch on our own. So future-wise, we want the automatic annotation to get better, or at least to help us out in facilitating the process in being faster. And also the second component is maybe after all, we don't need to annotate everything. And if we have large enough numbers and we say, let's say, for example, identify just places, this is going to be easy to do automatically. If you give them, like, let's say, what sort of places you're looking for, calculate that, give me a score. So, yeah, I think we can be a bit more optimistic with regard to the future of automatic annotation, but it takes time.
Thank you very much.